Intro. Hello everyone. Welcome back to our channel. Today, we are diving deep into an increasingly important topic in the world of machine learning and software engineering, building a continuous integration and continuous deployment (CI/CD) pipeline for machine learning models. In this video, we will explore how to automate deployment and monitor those models in production. We'll discuss the challenges involved, the best practices, and provide you with a comprehensive framework that you can start implementing right away. So, let's get started. What is CI/CD and why it's important for machine learning? Before we jump into the technical details, let's clarify what we mean by CI/CD. Continuous integration refers to the practice of automatically testing and building your code changes as soon as they are committed to a version control system. Continuous deployment, on the other hand, is the practice of automatically deploying those changes to a production environment after successful testing. Now, why does CI/CD matter for machine learning? Well, machine learning models are not static, they need to be updated regularly with new data, improved algorithms, or enhanced features. Automating the deployment process helps ensure that your models can be updated quickly and reliably while maintaining their performance in the real world. This is crucial for businesses that rely on real-time predictions or insights, as it allows them to adapt quickly to changes in their environment or data. Challenges in machine learning CI/CD. Building a CI/CD pipeline for machine learning is not without its challenges. One of the main issues is the complexity of the machine learning lifecycle itself. Unlike traditional software development, machine learning projects involve multiple components such as data preprocessing, model training, testing, and evaluation. Each of these components has its own challenges. For example, data quality can significantly impact model performance. If the data changes, your model may become less accurate, but if you rely solely on automated deployment, you might inadvertently deploy a model that performs poorly. Additionally, machine learning models can be resource-intensive, requiring substantial computational power for both training and inference. Another challenge is versioning. Keeping track of different model versions, data versions, and dependencies can quickly become complicated. You need a systematic way to handle these versions to ensure reproducibility and traceability. Key components of a machine learning CI/CD pipeline. Now that we've discussed the challenges, let's break down the key components of an effective CI/CD pipeline for machine learning models. First, version control. Use a version control system like Git for your code. For managing datasets and models, consider using tools like DVC, Data Version Control, or MLflow. These tools help you track changes in your datasets and models while allowing for collaboration among team members. Second, automated testing. Implement testing at different stages of the pipeline. You can create unit tests for your data processing functions, integration tests for the entire workflow, and performance tests to evaluate model accuracy. This ensures that any changes will not negatively impact the model's performance. Third, CI/CD tools. Use CI/CD tools like Jenkins, GitLab CI/CD, or GitHub Actions to automate the workflow. These tools can automate steps like running tests, building Docker images for your model, and deploying it to your production environment. Fourth, containerization. Containerize your machine learning models using Docker. This makes it easier to manage dependencies, ensures that your model runs in a consistent environment, and simplifies deployment to various platforms. Fifth, model registry. Use a model registry to manage model versions and metadata. MLflow and Selden are popular choices that allow you to track which model versions are deployed and their performance metrics. This is essential for rollback capabilities in case a new model version does not perform as expected. Sixth, monitoring and logging. Once your model is deployed, it's crucial to monitor its performance in real time. Set up monitoring tools to track metrics such as prediction accuracy, latency, and resource usage. Tools like Prometheus and Grafana can help visualize these metrics. Logging is also essential for diagnosing issues and improving model performance over time. Finally, feedback loop. Create a feedback loop to continuously improve your models. Collect data on model performance, user interactions, and any errors. This information will be invaluable for retraining your models to adapt to changes in data patterns over time. Step-by-step guide to build a CI/CD pipeline. Now that we have outlined the key components, let's walk through a step-by-step guide to building a CI/CD pipeline for machine learning models. Step 1. Set up version control. Start by initializing a Git repository for your project. Organize your code into clear directories for data, scripts, models, and tests. If you're using DVC, initialize it in your repository to manage your datasets and model files. Step 2. Develop automated tests. Create unit tests for your data preprocessing and training functions. Use a testing framework like PyTest. You should also include tests to check if your model meets certain accuracy thresholds. Use a validation dataset to ensure that your model's predictions are reliable. Step 3. Configure CI/CD tool. Choose a CI/CD tool that fits your team's needs and configure it to listen for changes in your Git repository. Set up workflows that define the steps to run your tests, build Docker images, and deploy models. Step 4. Containerize your model. Create a Docker file that specifies how to set up your environment and run your model. This file should include all necessary dependencies and instructions for running the model in production. Build and test your Docker container locally to ensure it works as expected. Step 5. Set up a model registry. Choose a model registry solution and integrate it with your workflow. When a model is trained and passes testing, register it with the model registry, including metadata such as version, training parameters, and performance metrics. Step 6. Deploy the model. Once the model is registered, automate its deployment to production. This could involve deploying it to a cloud service like AWS, Google Cloud, or Azure, or even to an on-premise server. Ensure that your CI/CD tool can handle the deployment of your Docker container. Step 7. Implement monitoring and logging. Set up monitoring tools to track the performance of your deployed model. Implement logging for both predictions and errors so that you can diagnose issues as they arise. This data will be critical for improving model performance in the future. Step 8. Create a feedback loop. Finally, establish a process for collecting feedback on model performance. This could involve setting up dashboards to visualize performance metrics or creating automated alerts for when certain thresholds are breached. Use this feedback to retrain and update your models regularly. Demonstrating the pipeline. At this point, you might be wondering how all of this comes together in a real-world scenario. Let's walk through a hypothetical example. Say we are building a predictive model for customer churn at a subscription-based company. First, we would gather historical data on customer behavior, usage patterns, and subscription details. We would pre-process this data and use a version control system like Git to track our code changes. As we develop our model, we would implement unit tests to ensure our pre-processing steps are working correctly. Next, once we're satisfied with our model's performance using a validation dataset, we'd configure our CI/CD tool to automate testing and deployment. We would create a Docker container that packages our model and all its dependencies, ensuring that it can run in any environment. Once our model is registered, we would deploy it to our production environment. But our work doesn't stop there. We would continuously monitor the model for performance, logging predictions, and any errors that arise. If we notice a drop in accuracy due to changes in customer behavior, we can use the feedback to retrain our model with the latest data, pushing it back through our CI/CD pipeline. Conclusion. Building a CI/CD pipeline for machine learning models is undoubtedly a challenging task, but it's also incredibly rewarding. The ability to automate deployment and monitor models in real time opens up new opportunities for businesses to harness the power of machine learning effectively. By following the guidelines and steps we've discussed today, you can establish a robust CI/CD pipeline tailored to your machine learning needs. If you found this video helpful, please give it a thumbs up, subscribe to our channel, and share it with your friends. And if you have any questions or comments, feel free to leave them down below. We'd love to hear your thoughts. Thank you for watching, and see you in the next video.